Reducing environmental impacts of petroleum refining. Title: Reducing environmental impacts of petroleum refining. Introduction, approximately 150 words. Petroleum refining is a crucial industry that plays a significant role in meeting the world's energy demands. However, the process of refining crude oil also has severe environmental implications. The extraction, transportation, and refining of petroleum contribute to air and water pollution, greenhouse gas emissions, and habitat destruction. As the global demand for energy continues to rise, it is essential to explore sustainable practices and technologies to minimize these negative impacts. This article discusses various strategies and technological advancements that aim to reduce the environmental footprint of petroleum refining. By adopting these measures, the industry can mitigate pollution, limit greenhouse gas emissions, and promote sustainable development in the energy sector. These gases contribute to climate change and global warming. To address this issue, the industry is increasingly adopting cleaner and more energy-efficient technologies. Carbon capture and storage, CCS. CCS involves capturing CO2 emissions from refineries and storing them underground, preventing their release into the atmosphere. This technology has shown promising results and can significantly reduce GHG emissions. B. Renewable energy integration. Integrating renewable energy sources like solar and wind power into refining operations can reduce the reliance on fossil fuels and lower emissions. Utilizing electricity generated from renewable sources for process heating can bring about substantial environmental benefits. C. Process optimization. Enhancing the efficiency of refining processes can lead to energy savings and subsequently reduce GHG emissions. Implementing advanced process control and employing catalysts that require lower temperatures can contribute to substantial emission reductions. 2. Water conservation and pollution prevention, approximately 300 words. Petroleum refining involves substantial water usage and discharges that can lead to pollution if not adequately managed. To reduce the industry's water footprint and safeguard water resources, the following strategies are being implemented. Water recycling and reuse. Refineries are exploring innovative ways to recycle and reuse water for various applications. This not only reduces freshwater intake but also minimizes the volume of wastewater discharged into water bodies. Advanced wastewater treatment technologies. Implementing advanced treatment technologies helps remove pollutants and contaminants from refinery wastewater. Techniques such as membrane filtration, biological treatment, and chemical precipitation can significantly improve effluent quality. C. Spill prevention and response. The petroleum industry continuously invests in spill prevention technologies and emergency response systems to minimize the impact of accidental releases. Improved monitoring and detection systems, as well as effective contingency plans, are crucial for preventing and addressing spills. The following approaches are being adopted. A. Cogeneration and combined heat and power, CHP. Cogeneration and CHP systems simultaneously produce electricity and useful heat. Implementing these systems can improve overall energy efficiency by utilizing the heat generated during power production for refining processes. Waste minimization and resource recovery. By identifying and implementing waste minimization practices, refineries can reduce both environmental impacts and costs. Techniques such as solvent recovery, material recycling, and waste heat recovery can contribute to resource optimization. C. Life cycle assessment. LCA. Conducting comprehensive life cycle assessments of refining processes allows for a detailed understanding of their environmental impacts. By identifying the hotspots within the life cycle, targeted improvements can be made to reduce overall environmental burdens. Reducing environmental impacts of petroleum refining, Part 2. 4. Air quality management, approximately 300 words. The refining of petroleum can release pollutants into the air, which can have detrimental effects on human health and the environment. Implementing effective air quality management strategies can help mitigate these impacts. The following measures are being adopted. A. Flare gas recovery. Flaring, the controlled burning of gases during refining operations, can release pollutants into the atmosphere. Implementing flare gas recovery systems can capture these gases and reduce emissions, resulting in improved air quality. These technologies help reduce emissions of nitrogen oxides, NOx, sulfur oxides, SOx, and volatile organic compounds, VOX. C. Dust control and particulate matter reduction. Refining operations can produce particulate matter, which can have adverse effects on air quality. Implementing effective dust control measures, such as installing dust collectors and employing efficient filtering systems, can help reduce the release of particulate matter into the atmosphere. 5. Biodiversity conservation and restoration, approximately 300 words. Petroleum refining can have significant impacts on natural habitats and biodiversity. To conserve and restore ecosystems affected by refining operations, the industry is taking the following steps. Environmental impact assessments, EIAs. Conducting comprehensive EIAs before commencing refinery projects helps identify potential impacts on biodiversity. This allows for the development of appropriate mitigation and restoration plans to safeguard ecosystems. B. Habitat restoration programs. Refineries are investing in habitat restoration programs to offset the impacts of their operations on biodiversity. These programs involve activities such as reforestation, wetland creation, and the preservation of native plant and animal species. C. Conservation partnerships. Collaborations with conservation organizations and local communities can help establish protected areas and implement conservation initiatives around refinery sites. These partnerships ensure the long-term preservation of biodiversity and the sustainable management of natural resources. 6. Stakeholder engagement and transparency, approximately 300 words. Engaging stakeholders and maintaining transparency in refining operations are crucial for addressing environmental impacts. The following practices are being adopted to promote accountability and build trust. Community engagement. Refineries are actively engaging with local communities to understand their concerns and involve them in decision-making processes. This includes regular communication, public consultations, and partnerships on environmental initiatives. Environmental reporting. Increasing transparency through regular environmental reporting helps stakeholders assess the performance of refineries in reducing their environmental impacts. Reporting on key metrics, such as emissions, water usage, and waste generation, enables benchmarking and the identification of areas for improvement. C. Certification and standards compliance. Refineries are pursuing certifications and compliance with industry standards, such as the ISO 14001 Environmental Management Standard.